Hello friends, in this video, let us learn the bubble sort algorithm implementation. So in the previous video, we have learned how bubble sort works and we designed an algorithm for it. So let us quickly revise it. We will have the array and in bubble sort, we will continuously compare adjacent elements and after first cycle of comparison, the largest element will reach the last position. And we will compare the remaining elements then and the largest element of these will then come to the second last position. And this will continue and finally we will get the sorted array. So that was bubble sort. So in this video, let us learn the bubble sort algorithm implementation, how it works in step by step. So we have the function bubble sort, which takes the array to be sorted and its size as parameters. So we have this array with elements 50, 25, 5, 20 and 10. And its size is 5. And here we will use a nested for loop. The inner for loop will compare the adjacent elements and swap if needed. And this should be done for size minus 1 times to get the sorted array. And for that, we have the outer for loop which will run size minus 1 times. So first, we declare I and j. And we have the outer for loop and in first iteration, I is equal to 0. And for the inner loop, in first iteration, j is equal to 0. And we have if ARR of j greater than ARR of j plus 1. That is, we are comparing two adjacent elements. And if the first one is larger than the second, it is not in the right order. So we have to swap. That is, if this condition is true, the first one is larger than the second one. So swap ARR of j and ARR of j plus 1. Here, ARR of j is equal to 50 and ARR of j plus 1 is equal to 25. And we have 50 greater than 25. So if is true, so swap these two elements. Now in the next iteration, j is equal to 1 and we have if ARR of j greater than ARR of j plus 1, that is we are comparing the elements at index 1 and 2 and we have 50 greater than 5. So if is again true, so we have to swap. Now in the next iteration, j is equal to 2 and we have if ARR of j greater than ARR of j plus 1. That is we are comparing elements at index 2 and 3. And we have 50 greater than 20. So if is true, so we have to swap these two elements. So 50 and 20 are swapped. Now in the next iteration, j is equal to 3. Again we have to compare the elements at index 3 and 4. And we have 50 greater than 10. So if is again true, so we have to swap these two elements. Now in the next iteration, j is equal to 4. And now the condition j less than size minus 1 minus I fails since 4 is not less than 4. So the first iteration of outer loop is now completed. That is, the first cycle of comparison is done and we got the largest element in the correct position. And this is what bubble sort does. In each iteration of outer for loop, one element comes to right position. And from now, we won't consider it as it is already sorted. And that is why we have the condition j less than size minus 1 minus I in inner for loop. Now in the second iteration of outer for loop, I is equal to 1. And inside, we have the inner for loop. And in first iteration of this loop, j is equal to 0. And we have if ARR of j greater than ARR of j plus 1. And we are comparing the elements at index 0 and 1. And we have 25 greater than 5. So if is true here, so we have to swap these two elements. Now in the next iteration, j is equal to 1. And we have if ARR of j greater than ARR of j plus 1. That is, we are comparing elements at index 1 and 2. And we have 25 greater than 20. So if is true here also, so we have to swap 25 and 20. And it is done. And in the next iteration, j is equal to 2. And we have if ARR of j greater than ARR of j plus 1. That is we are comparing the elements at index 2 and 3. And we have 25 greater than 10. So if is true here also, so we have to swap 25 and 10. Now in the next iteration, j is equal to 3. But now the condition j less than size minus 1 minus I fails. So second iteration of outer for loop is also completed now. And we got the second largest element also sorted. Now in the third iteration of outer loop, I is equal to 2. And inside we have the inner for loop, and in first iteration of this loop, j equal to 0. And we have if ARR of j greater than ARR of j plus 1. That is, we are comparing the elements at index 0 and 0 plus 1, that is 1. And we have 5 not greater than 20. So if fails, that is, these two elements are already in sorted order. So there is no need to swap them. Now in the next iteration, j is equal to 1. And we have if ARR of j greater than ARR of j plus 1. That is, if ARR of 1 greater than ARR of 2. And we have 20 greater than 10. So if is true, so we have to swap these two elements. So 20 and 10 are swapped now. Now in the next iteration, j is equal to 2. But now the condition j less than size minus 1 minus I, that is 5 minus 1 minus 2, which is j less than 2, fails as 2 is not less than 2. So third iteration of outer for loop is also completed now. And we got the third largest element at the right place. Now in the fourth iteration of outer loop, I is equal to 3. And inside we have the inner for loop, and in first iteration of this inner for loop, j is equal to 0. And we have if ARR of j greater than ARR of j plus 1. That is, we are comparing the elements at index 0 and 1. And we have 5 not greater than 10. So if fails here, that is, these two elements are already in sorted order, so we don't need to swap them. Now in the next iteration, j is equal to 1. But now the condition j less than size minus 1 minus I fails as 1 is not less than 1. So fourth iteration of outer for loop is also completed. And we got the fourth largest element also sorted. Now in the next iteration of outer loop, I is equal to 4. But now the condition I less than size minus 1 fails as 4 is not less than 4. And now the control comes out of the loop and we got the array sorted. So that is how bubble sort function works. Now let us take a sorted array and analyze it. If we give this array to our bubble sort function, it will first compare the first and second elements. Since they are in sorted order, there is no need to swap. Next, it will compare second and third elements, and it is also in sorted order, so again there is no need to swap. Similarly, all comparisons will fail and we can understand that there is no need to swap. It is already sorted. But however, our bubble sort function will go on to the next cycle and compare the first 4 elements again, and in the next cycle the first 3 elements will be compared, and this will continue. So the program is unnecessarily comparing the sorted elements and wasting CPU time. So what can we do here? We can notice that the sorted array doesn't need any swap operation. So if no swap operation takes place, we can be sure that the array is sorted and we can break the process. It will improve the efficiency of bubble sort algorithm. Let us see how. There is only a small change that we need to make in this function. We will declare a flag variable and initialize it to 0 in the beginning of each iteration of the outer loop. And whenever a swap operation takes place, we will set flag equal to 1. And at the end of each iteration, we will check if flag is still equal to 0. Then we can understand that no swap operation took place, so we can break out of the loop. So see here, we have a sorted array of size 5. And we pass this array to the function, and in first iteration of outer loop, I is equal to 0. And we declare an initialize flag to 0. And in first iteration of inner loop, j is equal to 0, and we compare elements at j and j plus 1, that is 0 and 1. And we have 10 not greater than 20, so no swap. And in next iteration, j is equal to 1. and we compare elements at j and j plus 1, that is 1 and 2. And 20 is not greater than 30, so there is no swap again. And in the next iteration, j is equal to 2. And we compare elements at 2 and 3, and we have 30 not greater than 40. So again, there is no swap. And in next iteration, j is equal to 3. And we compare elements at j and j plus 1, that is 3 and 4. And we have 40 not greater than 50. So again, there is no swap. And in next iteration, j is equal to 4, and now the for loop condition fails and control comes out of the inner for loop. And it checks if flag is still equal to 0. And it is. So it means that there was no swap operation and the elements are sorted and we can break out of the loop. So we have saved a lot of time and improved the efficiency of bubble sort function using this method. If this was the old function, it would have gone for 3 more iterations of outer for loop, each with inner for loop running for size minus 1 minus I times. And now suppose the input array was not sorted and there was one unsorted element, and in the first iteration there was one swap operation which sets flag equal to 1, and also in this iteration the array becomes sorted. So in the second iteration of outer for loop, there will be no swap operation. So when it checks for the flag value, it will be equal to 0. So the process will be stopped there. That is, whenever the array becomes sorted, we can stop the process right there. So this is how bubble sort algorithm works, and we also learned how to improve the efficiency of this algorithm. So in the next video, we will analyze the time and space complexity of the bubble sort algorithm.